In the previous lesson, if you remember, we looked at the concept of atoms for the purposes of chemistry. Now, this was just a very basic foundational concept, looking at the concept of subatomic particles, looking at the differences in terms of mass as well as charge of subatomic particles, the location of subatomic particles around the atom. And in this lesson, what we're going to do is talk a little bit about the concept of isotopes, because this lesson is going to focus on essentially a logical consequence of our knowledge relating to the structure of atoms, and this is what isotopes essentially are. Because we know already from the previous lesson a number of fundamental facts. So we know, for example, that atoms are made up of three subatomic particles. They're made up of protons, they're made up of neutrons, and they're made up of electrons. That's the first thing that we know for the purposes of the nature of the atom. We also know about different things relating to the concept of determining the element of an atom. So we know, for example, that the proton number, or the number of protons, will determine the element of the atom. So if I was to write, for example, for example, if I was to write this right here, I was to write AU, and I was to write that AU has 79 protons, and the mass is around 197. Okay, this is an element here. Now, I know for a fact that the determination of what this element is based on this number here, the number of protons. Now, I happen to know that this is the element of gold. So we can determine that the mass number, which is up here, okay, doesn't determine the element. It is the proton number, the number of protons down here. So from there, we can... Oh, actually, that was the example that I used on the screen. I didn't actually realize that was going to be the example. Okay, but we also know from this information that different atoms will have a different atomic mass. So, for example, this is an example of gold, but we can also write, for example, this element down here, Na. This is sodium, and this has an atomic number of 11, and it has a mass number of 23. So these two are different elements because they have different protons. They have different numbers of protons. One has 79 and one has 11. But they also have different masses. One has 197 mass and one has 23 mass. So atomic mass is something that's quite important. But how do we determine atomic mass for the purposes of chemistry? Well, since electrons are incredibly small, something that we looked at in the last lesson, we know that electrons are incredibly small. And so therefore their mass is essentially negligent for the purposes of chemistry, because their masses are, compared to neutrons and protons, are completely, are not worth considering. We only need to calculate the mass of the number of protons as well as the number of neutrons. So we can come to the conclusion that the mass number of an element is equal to the number of protons, which we represent as Z, plus the number of neutrons. This is equal to the mass number. Now, this brings us into question the idea of isotopes, because isotopes are quite an interesting logical consequence of this mass number and this mass number determination. What if we have a situation where we have the same number of protons between two different atoms, but they have different neutrons? What happens then? Well, in this regard, there can exist two elements that are exactly the same, okay, two of the same element, so two atoms that both have the same number of protons, that have both the same atomic number, but they have different atomic masses because they have different numbers of neutrons. So, in this sense, we have what are known as isotopes. So, we define an isotope as atoms with the same number of protons but with different numbers of neutrons, and therefore, as a result of this, therefore, different mass. So different mass. So that's quite interesting. Oh, I've written over there. It is not the case. It is not the case that any number of neutrons, though, will be stable to form any number of isotopes. So it's not like there is an infinite number of isotopes for gold because there's an infinite number of neutrons that can exist within the nucleus of a gold atom. This is not the case. In fact, depending on the element that we have a number of different stable isotopes in existence. Some have more, some have less. The heavier we go in terms of the heavier the atom goes, the element goes, we start getting down to things like plutonium and uranium. We start to see that they have more and more different isotopes because they have more and more different combinations of neutrons to protons in the nucleus to form different masses. So let's take an example of an element that is very important for chemistry, that is carbon, and the stable isotopes that carbon has. Carbon has 3 stable isotopes. You have carbon, if we write carbon here, okay, we know already, if you have a look at your periodic table, that carbon has a proton number of 6, okay? So every single variation of carbon, all 3 of these isotopes will all have the same number of protons. They all have 6. But we then have 3 different masses. We have carbon 12, carbon 13, and carbon 14. So these are 3 different elements that are, 3 different atoms that are the exact same element. They are all carbon, okay, but they have 3 different masses because they have different neutrons. Different neutrons. And in some regards, the number of neutrons and the mass that you have for different isotopes of, say, carbon or any other element, okay, doesn't actually make that much of a difference in terms of the effect that it has on the properties of that particular isotope itself. But in a lot of senses and in a lot of regards, it in fact does make a very big difference in terms of some being more radioactive than others, okay, having the propensity to decay through radiation, and then some having different properties as well in other regards. So we will come to conclusions and we will come to looking at different isotopes as we go on through chemistry, but it should be noted that this is the explanation for what isotopes are, and this is an example of an element that has 3 different isotopes, namely that being carbon.